Hello students, welcome to my channel. So today we are going to study about the same topic of the previous, that is like reflection and refraction, but this is part 3, okay? So obviously there will be something new. Don't think I'm going to start with the previous one. So if you've not seen the previous videos, please go and check it out. Don't directly come to this, okay? You may not understand it. Okay, now today what we are going to study is about sign convention. Yeah, we are going to start about the numerical problems in this chapter. So in previous videos we have not started with them. So this chapter has lots of numerical problems. So to to do those numerical problems, you have to understand how to take the values. Like in other numerical values, numerical problems in electricity chapter and others, they will like positive numbers, negative numbers, like addition, subtraction, but you know what happens every time. So here also we should take some in positive, some in negative. We have to understand what we should take in positive, what we should take in negative. Simply we cannot put values and calculate. So numerical problems means first we have to study about sign convention in this chapter. So I'm going to teach about sign convention first. Don't worry, you will get some idea. Buddy. Okay, so we are going to study about sign convention. Now this sign convention, have you heard Cartesian sign, Cartesian convention? Okay, so you might have heard of this Cartesian plane, right? Where center is O, negative, then 1, 2, 3, 4, x-axis, y-axis, then negative y-axis, negative x-axis. You might have seen this, right? So this is also something same. Just values we are referring according to this only, which are positive, which are, but diagrammatically when we draw it, it's different. Okay, so let me draw it once. Okay, this is as usual our mirror, concave mirror. Okay, guys. So see this diagram properly. Okay, concentrate. What I'm going to tell you. So usually here, the direction upwards, height upwards is calculated in positive. Like if you keep an object here, okay, an object here of thing 6 centimeter height. So this height, when you write it in numerical problems, you have to take it positive height. You might think, sir, what is this, sir? Always a positive and you will take no, so how it can be negative? Well, let me tell you about this. Distance towards left is negative if the object is kept here, you think. Okay. So when you calculate the distance of this object, always you have to calculate from the pole. Now where is the pole? Here. This is the pole. So always the distance you have to calculate from the pole. That is from pole to the object. So when you calculate from the pole to object, just check this. When you come this side, it's negative, right? In Cartesian plane. So this is an easy method. Just you remember this so that you will get the way to use positive and way to use negative. So when you come from pole towards object, towards left side, that time the distance whatever you get, like 6 meter, 2 meter or 2 centimeter, any value, you have to write negative and bracket right due to sign convention. Okay, what is sign convention? This, as it is. These are the rules. Okay, which one you should take positive, which one you should take negative. Now if the image will be always formed here, right, in concave mirror. Okay, so they may ask you to find the image height of the image. Okay, if you keep the object here, object height is there. So when the image is formed, it also has some height, right? So the height of the object is also taken negative, okay, because it's coming towards left. Direction towards left is negative. So from pole, when the direction we calculate towards left side, we have to take it negative. Okay, but as our image is downwards, so the height of the image comes negative. Just check this, downwards, it is negative y-axis. So same way here also, when you calculate downwards, you will get negative. The height comes negative, but upward the height is positive, down the height is negative. It is clear, right? Okay, now let's go to this side. Direction towards right. So towards right means it is positive x-axis in the Cartesian plane. So same way here, when you calculate the distance towards right, direction towards right, or the distance towards right. So sometimes you might have studied in a concave mirror, sometimes the image is formed either side of the mirror. So at that time they ask you to find the distance of the image formation, means how far the image is formed. So that time you have to, you may get image here somewhere. The distance you have to calculate from the pole. So when you calculate in right side, when you calculate in the right side, you have to take it positive. Left side negative, right side positive, left side negative. Upwards height positive, downwards height negative, upward side positive, downward side negative. Okay, I hope you guys understood this properly. Behind this properly, this diagram, understand it carefully so that you will not go wrong while taking the values. Okay, now you have to there's a formula. Okay, only one formula in mirror case, whereas we'll go next to lens. Okay, there is another one formula. For mirror you have to use this formula. Okay, so here V stands for image distance and U stands for object distance and F stands for focal length of the mirror. Okay, sometimes they'll give focal length and image distance, means image is formed at so far from the object, so far from the mirror, and the mirror has focal length of so and so, and they may ask you to find the object distance of object, means how far the object is kept, to obtain the image so far by using a mirror of certain focal length. So that time you have to apply this formula. You have to put the values given here and the focal length so that you can get the value of U. Okay, same way you can find the value of F, you can find the value of V, that is image distance, object distance, focal length. I'll write it separately for you guys. Okay, so this one deals with image. Okay, image distance is how far the image is formed from the mirror. When you calculate the distance from the mirror, how far the image is formed, and how far the object is kept, that is object distance denoted by u, and focal length. Now if you have seen the part 1 of this video, part 1 of this topic which I have done, you might have heard from me that I didn't tell you guys where to use this focal length. Okay, I just told you guys what is focal length, but I didn't tell you guys where it is used. But I had mentioned that it will be used in further, I will be explaining you, that is in when you go to numerical problems. So here when you come to numerical part, this focal length is very important. Okay, it will be used in most of the sums, so don't forget this. Okay, if you remember this concept properly, then numerical problems will be very easy for you guys. Okay students, so there's one more formula which I want to tell you about magnification. So you know now, if you keep an object here and you will obtain an image, sometimes you will observe it as magnified, not magnified. So based on its size we can say it. So to calculate whether the image is magnified or diminished, there's one formula. Okay, so the formula is I don't have space here, so I'll write it here. M is equal to h dash by h. Okay, M is equal to h dash by h. So here h dash is the height of the image, okay, and h is the height of the object. But sometimes now to find this h dash and h, if they give, okay, it's very nice. If they won't give, then we have to find it in other way. Okay, if they by using the distance. Okay, so by using the distance also we can find out the magnification of the object. So for that, the formula is M is equal to minus V by U. Now if you guys know what is V and what is U, that is V is the image distance and U is the object distance. So there are two formulas to find magnification. Okay, if the magnification is negative, then you can say diminished. If magnification is positive, then you can say it is enlarged. Okay, so this is what these two formulas are used. Okay students, so I hope you guys now you are familiar with all the formulas. If not, just rewind the video and once again note down all the formulas, okay, and keep them aside unless you are not perfect with all the formulas. Okay, now here I come with a numerical problem. Okay, actually I have chosen this very big numerical problem because in this, to solve this numerical problem, we are going to use all the formulas. So it's going to cover almost all of our formulas. Okay, so but after a lot of searching, I have got this. So please concentrate. So here I'll first read out the problem here. An object of size 5 centimeter. Okay, so there is an object which has a size of 5 centimeter is placed at a distance of 20 centimeter from the concave mirror. So what we are dealing here with? A concave mirror. So think there is a concave mirror. Okay, then we are keeping an object at 20 centimeter away from the mirror. Okay, and what is the size of the there's a mirror, concave mirror. We are keeping the object 20 centimeter away from the mirror, and the size of the object is 5 centimeter. Okay, I hope this much is clear. Now we need a focal length of that concave mirror. Now all concave mirrors are not same because the focal length varies. So there should be a fixed focal length for a concave mirror. Otherwise, we cannot calculate anything with that. Okay. So here they have given us a focal length that is 15 centimeter. So what is the focal length of that mirror? 15 centimeter. So after getting this and all information, you have to note it down according to sign convention. Means which one is positive, which one is negative. Now here we have got focal length as 15 centimeter. Doesn't mean that we can write focal length is equal to 15 centimeter. Wrong. You lose the marks. Why? Because according to sign convention, if you rewind the video, you will get it. What I said is that when you calculate the focal length, that is the focal length from the mirror, we are calculating the distance towards left side. Okay, left side. So always when you calculate towards left side, it comes towards the negative x-axis, so it is negative. Okay, so you have to write the focal length of the mirror is equal to minus 15 centimeter. Front you put a bracket and write due to sign convention. Okay, due to sign convention. Okay, so in the same way, height this size we have to write it in terms of height. Okay, the height of the object is 5 centimeter. Okay, now as the height is calculated from principal axis upward, the object is always placed upward of the principal axis, so we have to calculate the height from principal axis to upwards. So when you move upwards, it is positive y axis. Now I showed you in Cartesian plane drawn at side. Okay, in just previous slide of this. So you saw when we calculate upward, it indicates the positive y axis. So the height above principal axis is positive. Okay, and as this is a concave mirror, so there are more chances of getting the image below the principal axis. Okay, so they are asking us here, never mind, if they ask us the size of the image, we have to write it in terms of negative. The height we get it in terms of negative. Okay, of the image, not of object. Object height is positive. Image height, if they ask, we have to write it in negatives. Okay, now let's see what they have asked. This is what they have given us. Till here, they have given us all the values or the parameters or all the clues by using which we have to find something. Now, what is that something that we have to find? Here it is. At what distance from the mirror? At what distance from the mirror should a screen to be placed to get a sharp image? Okay, now to place a screen, what does it mean? Where the object will be formed, there you have to place the screen to capture a sharp image. If you keep it somewhere else, you will get the image, but it will be blurred. You won't get a sharp image. Like if you have worked with the projectors in your classrooms, if you have smart board, you will have projector in your class. So when you move the projector, the focal length changes. So you get a blur image. So same way, to get a sharp image, you have to keep the screen at a point where you can, at a point where the image is formed to capture a sharp image. So you have to find out where the image is formed. So there you can place the screen. Okay. So at what distance from the mirror should a screen to be placed to get a sharp image? I hope this is clear. Now let's see. Also calculate the size of the image. Also calculate the size of the image and state the nature of the image. Okay, now about this nature and all I explained in the second video. If you have not seen, please watch the part 2 of this topic. Okay, then you will be clear with what is this. State the nature of the image. What is this nature and all? You will understand it. So now if you understood the question, please copy it down because I am going to erase it to solve. Okay, please copy it down fast. Okay students, so I hope you guys have noted down the question. Even I have noted down the question here. So I am going to solve it. How we are going to solve, step by step I will go on explaining also. So first you have to write given. Okay, given. So here what parameters they have given, that we have to write it according to sign convention. So first comes object distance. So object distance, that is u. Okay, denoted by u. So what object distance they have given us is 20 centimeter. But as it is kept left side of the mirror, we have to take it minus. Okay, minus according to sign convention. According to sign convention. As there is no space, I am writing short form. Okay, but it's better you write it in a expanded way. Don't write short form. Okay, I don't have space, so I am writing it. Now focal length of the mirror. Denoted by f. Okay, even the focal length is in negative, 15 centimeter due to sign convention. The next comes object height. Object height denoted by h, and this one is positive, 5 centimeter. Okay, so these all values are the parameters what we have got from the question. If you want, you can check it once if you have copied the question. Okay, now we are going to start our solution. Now first what they have asked is, at what distance from the mirror should the screen be kept to get a sharp image. Okay, so always when we find the distance of the image distance, we have to use the mirror formula. Okay, so as I told you, what is mirror formula is okay, so this is a mirror formula. Okay, don't forget this. Now let's put our values in this. So what we have, f value here, negative 15, minus 15 centimeter. So here we go, minus 15. Image distance is what we have to find here. Okay, and object distance we have got negative, that is 20 centimeter, minus 20 centimeter. Okay, so minus 20 centimeter. Okay, now let's calculate the image distance. Okay, so we got the image distance as minus 60 centimeter. So this tells us that to obtain a sharp image of the image, we have to place the screen 60 centimeter away from the mirror. Okay, so we found the first we found the object image distance. Okay, that is 60 centimeter. Okay, now next let's see what they are asked. Other than this. Okay, so they asked us to find the size of the image. So to find the size of the image, we should first find out what is the height of the image. So that will be the size of the image. Now to find the size of the image, we have two formulas, about the magnification. Well, we don't know both heights, so we are going to use the second formula, that is m is equal to minus v by u. Okay, so based on what we have to decide which formula to use. Now there is another formula which is h dash by h. We don't have both the h here, and we have to find h dash, and even we don't know what is magnification also. So first we will find the magnification, then we will put it in the second formula to find the h dash, that is image height, so that we can get to know the size of the image. Okay. I hope you guys are understanding what I am saying. Okay, if you are not understanding, please write in the comment section which part you didn't understand, so that in the next video of this chapter I will be clarifying those doubts. Okay. Okay, so here we are using the second formula of the magnification, that is m is equal to minus v by u. So v value we got it as minus 60. So that is what we have to find in the place of v, that is minus 60, and u value we got it from the question, that is minus 20 centimeter. So minus 20. Now here both the signs are going to get cancelled. Okay, so m is equal to minus 60 by minus 20. 0 0 cancel, 2 1s are 2 3s are. So therefore magnification is equal to minus 3 centimeter. Okay. So as we got the magnification and negative, we get to know that the image form is smaller than the object. So it is diminished. When we get the magnification value in the negative, this tells us that the image is diminished. If we get it in the positive, then we get to know that image is enlarged. Okay, so we have got to know that image is diminished. Now as we got this, now by using the magnification, we have to find the size of the image. Okay, now the magnification we got is minus 3. Now let's use the first formula of the magnification, that is m is equal to h dash by h. So as I said, the height is the size of the image and h dash is the height or the size of the image. H is the size of the object. Okay, h is the height and the size of the object. H dash, we can say the height of the image or even the size of the image. Okay, so we have to find the h dash. Now we have the height here, that is positive 5 centimeter. That is the size of the object, and magnification we already found here. Now by using this value and this value, we have to find the h dash value. So I'll erase this because I don't have enough space here. Let's put our values here. Okay, so here the size of the image we are getting it as minus 15 centimeter. Okay, so this is the size of the image. So I hope you guys understood how we used all the formulas and solved this sum. So this is the height of the image. Okay, h dash, don't forget this. Okay, now they asked you the nature of the image. So as the nature of the image in the concave mirror is most likely to be real and inverted, and we got it not to be magnified, so we get it, sorry, in the negatives. Okay, it is in the negatives because it is in the downwards. Okay, so the nature of the image we get is as nature of the image is real, inverted and diminished. Now as it is in minus, as I said, the size decreases, so it becomes diminished. So the nature of the object is real, inverted and diminished. I hope you guys understood. Okay guys, so thank you for watching my video, and please keep on encouraging me by please like, share and subscribe my channel, and please turn the bell icon to blue. Okay, and if you really learned something from my today's video, then I'll be very happy. And please write in the comment section what and all you learned today. Was it really informative? So it encourages me to put some more videos to teach you guys some more. So thank you for watching. Jai Hind.